All right, now we're going to continue with our last two types of radioactive decay. So the first one is related to beta decay because it involves electrons. It's called electron capture. And it's exactly what it sounds like it is. Essentially, a radioactive nucleus, an unstable one, will grab one of its own electrons and change into a different nucleus, different type of nucleus. So one example of this would be beryllium 7,4, and it gains an electron and it becomes lithium 7,3. And again, because we're dealing with electrons here, we also pick up a neutrino, and this time, in this case, it's an electron neutrino as a decay product here. Okay, so beryllium grabs that electron, and as you can see here, in general, we have our charge conservation again. So let's write this one in general so we can see what it looks like. So we start with our unstable nucleus, a Z, and then it grabs one of its own electrons from the inner orbital usually. So we label that as 0, -1. And then again, we want the numbers, the above and below, to add up. Okay, so on the top, we're still going to have A nucleons for our daughter nucleus, but now we're going to have Z -1. So we've lost a proton and gained a neutron in this process. And that's what we call electron capture. Sometimes they refer to it as K capture because the electron that's being captured is an inner shell electron that's in what is sometimes referred to as the K shell. Okay, so, and effectively you've got a proton becoming a neutron. So that's the last of the beta decays. And then the last type of radioactive decay we talk about is gamma decay. So in gamma decay, you have a gamma particle that is emitted. And in this case, we also will say instead of a gamma particle or a gamma ray is emitted. Okay, and as we know, we've heard of this name before, a gamma ray is a high energy photon. Okay, so this is a photon not being released because an electron is jumping around energy levels in an atom, but because there's a change in the nucleus that's emitting a very high energy photon. So what does this look like in general? So typically the way this one works is you start with an excited nucleus. So we put a little star there to symbolize that this is an excited. So it's the protons and neutrons inside the nucleus are in an excited state. They're not in their ground state. Okay, and then it decays down to its ground state for the protons and neutrons. Okay, so this is different than the electron states. And in the process, a gamma particle, a high energy photon, is emitted. Okay, so now you might say, well, where does an excited nucleus come from? How does that happen? Well, it's usually the result of another radioactive decay. So another radioactive decay leaves a nucleus in an excited state, and then it relaxes down to its ground state. One example of that is when boron here, boron 12, decays to carbon 12. Okay. And you can see that this is a beta minus decay. Okay, because we've gone from 5 protons to 6 protons there. But this carbon